Okay, one other way of thinking about this invisible wall strategy is instead of using our invisible wall to physically block us from walking through it, we could create an invisible collider that we can walk through, but that when collided with does something. And so, for example, I'm going to create a situation where we start with the lights off inside this little house, and then when we walk into the house, the lights turn on. So I'm going to start by creating a 3D object cube. I'm going to reset its transform, and then let's make it real big. And I'm going to put it in the house. So when we walk into the space of this cube, then something will happen. Okay, that'll be the shape. So step one is let's make it invisible again. I'm going to turn off its mesh renderer. And now you can just see the wireframe of the collider. But even still, we've made an invisible wall, and if we tried to walk into it, it would stop us. We wouldn't be able to enter the house. So instead of that, we want to go down to the box collider and change it to is trigger. So we're going to turn that on. So now what that means is we can walk straight into and through that collider without being stopped, but Unity registers that we have collided with it, and it functions as a trigger that can then be used in code. Okay, now there is that dirty word that I've been avoiding this whole time. I have been making these with the context that I'm teaching a class where nobody knows how to code. We don't have any prerequisites that you've ever taken a coding class before, and I myself am not a trained computer programmer. I don't really know how to code either. But in the spirit of demystifying it and making you see that it is not as intimidating as it seems, or at least the basics of it are not, we're going to do some very simple coding together just to make this happen. So a lot of the interactivity that you think of from games and interactive experiences, visual novels and walking simulators and stuff like that are achieved through coding with a kind of logic that, like, if certain conditions are met, then we should do something. and so we're going to write a little piece of code that follows that kind of logic. So the way this works is in our main assets folder, I have created a new folder called scripts. And scripts, a script is Unity's term for a short piece of code that can be dragged onto a game object and become a component. So we're going to make our own custom component here. And I'm going to right click in the empty space here and do create C# script. C# is just the name for the language, the programming language that Unity writes scripts in. So I'm going to call this light on, all one word, but I'll make on capitalized as well as light. So it's just a single word, no space. And I'm going to double click it and it will open up in Visual Studio, is the default code editor that Unity works with. So I'll give you a quick tour. At the top of a Unity script, there are what's called namespaces. And this is basically like which pieces of already existing Unity code will this script refer to. So it comes with some by default, and that'll be enough for us, but later, should we write anything that refers specifically to pieces of code that are only like in the XR interaction toolkit or whatever, we would have to add those namespaces here. Sort of like when you're in the package manager and you have to add certain things for Unity to have that functionality. It doesn't have it out of the box until you install it. This is kind of referring to whichever pieces of code we're going to need. So Then we have the public class light on, and that's this. That's what we're writing right now. And inside of that, it has two sections. It has a section called start, and it's got a comment here. Comments are noted by / in front of them, and comments don't do anything for the code. The code ignores them. They just tell the code writer or anyone who reads it what's going on here. So anyway, what this says is start is called before the first frame. So this happens at the beginning of running this piece of code. And then update is called once per frame. So things that would need to happen every single frame of the game, like a piece of code that needs to happen while you're moving your character around or whatever, would go in update. Things that just happen the one time can go in start. Now, with all that said, we don't actually need to do either a frame-by-frame update or a start. In this case, this is just like what comes in a Unity script by default. So I can select those and delete them and make an even simpler piece of code. So what we're going to do here is start by going inside this curly bracket, which is a way of organizing, like everything in between the curly brackets is a chunk of code that is the public class light on. Inside these curly brackets, we're going to write that piece of code. I'm going to start by declaring a public variable. It's going to be a light, and I'm going to name the light my light, and then I put a semicolon at the end. So what this means is that we're going to have this piece of code look for something, and it's going to find it publicly, which in Unity means we can access it in the inspector. So we'll be able to drag this something into a box right there in the inspector. It's a public variable. It can also have private variables that aren't accessible from the inspector, but I want mine to be. So I'm going to make this public variable, and what goes in that box, not just any old thing, a light. So the light is something that Unity recognizes, and it won't let us drag things that aren't lights into that box. And then here we're just making up a name for it. We want some particular light, and we're calling it my light. And then the semicolon is just there sort of as like, this marks the end of the line. There's no more thoughts in this particular sentence. So now that we've got our light, we've got to say, if somebody collides with a trigger collider, we got to turn this light on. So that somebody colliding with the trigger collider is a piece of code that already exists in the Unity engine. So the way we refer to that is we're going to have a private void on trigger enter. And that means it's not returning any information, I think. I think that's what the void refers to. And it doesn't need to be accessible outside this piece of code. So that's what the private refers to. But this on trigger enter business, you notice as I start to type it, Visual Studio knows that it exists already. And that's because we are using the namespace that has this piece of code already. So once I see it, I can hit tab and it'll finish my thought for me. So now we have this piece of code that's ready to go, but we just have to alter one part of it. So we're calling this on trigger enter, and then it's looking for a collider. That's the trigger that will be entered, and this is the name of the collider. And I'm just going to give it a different name than other, because I don't think other would be a useful name. So I'm just going to give it the short abbreviated name call for collider, COL. And then we're going to create an if statement. So the logic, remember, is if something enters this trigger collider, then we should turn on the light, right? So we'll start by saying if, and then in parentheses, I'm going to say our collider variable call dot game object dot tag equals player. So in plain English, what this is saying is if this particular collider's game object tag is exactly equal to the word player, and then you don't have to write the word then, but the logic is then, do this piece of code. And what we're going to do is turn on the light. So how you do that is my light, which is the light we collected up here, dot enabled. So this is the property of the light, whether the light is enabled or not, equals true. And so that enabled is looking for the word either true or false, because it's what's called a Boolean variable, which means true or false. And then we put a semicolon at the end of that statement. The reason we don't do it up in if is because we weren't done with the sentence. So if the collider's tag is player, that's not a full sentence, it's not a full thought, so we don't end the sentence there. Then execute this. And then we don't have to say anything else. You know, there's sort of an implied logic that if it's not player, just don't do anything at all. And so that's the entirety of this script. We've basically said, hey, here's a light, and if somebody's entered a particular collider and that somebody is tagged player, then turn on the light. Okay? So we're going to save this and jump back to Unity. So now we're back in Unity. We've got to link up a couple of things to make this work. So here is our house cube. This is the house collider. So I'm going to rename it that, and maybe I'll put it childed under house so that it all lives together and that makes sense. This house collider is what we have to add the script to that we just wrote. And the reason that is this is the collider that we want picking up whether it collided with our player or not. So we're going to grab light on and drag it over as a component of this collider. So then remember, we said light on was going to look for a variable that was a light. So here that is. Here's my light. And we made that. And we get to take a spotlight, or any kind of light really, and drag it into there. So now this script knows that that's the light that we're turning on. And speaking of turning it on, remember all this script can do is enable the light. So that means that this light needs to not be enabled at the beginning of the game. So, you know, when you first put in your light and make it pretty and pick the color and brightness and all that, it's going to be enabled. So then, you know, if your piece of code, if all it does is turn on a light, well, the light's already on, so it won't do anything at all. So we need to make sure we disable that light. And so what this piece of code is referring to is this light component, not the complete game object. That would just be a different piece of code to enable the whole game object. So this thing that says light, that's what we want to start unchecked, and then our piece of code should check it for us once we walk in. So we've got the light hooked up, we've got the light disabled from the start, and the only other thing that our script expected was a tag that says player on whatever walks into this room. So what's going to walk into the room is our XR origin. So if you click that game object, under its name in the inspector, the next thing down you'll see tag, and it says untagged, and most things in Unity are untagged by default. But when you pull that down, you'll see what the default tags are. Unity has some that are like already made, and player is one of them. if you need to make your own tags, you can add tags. So if you found it useful to have a tag that was like key or power up or whatever that you wanted to execute code on, you could. But so we're gonna set the player tag on the XR origin. So now that should be everything we need to do. I'm gonna hit play. And here's the moment of truth. Let's walk in and see if it works. Hey, there's our light. Sweet. So as soon as I pass the boundaries of that collider, then my light turned on. So what's cool about this is not only did we sort of code our first piece of code together, but the other thing that is useful about code is that it's fairly modular. That is to say, if we wanted to change this to not be a light but a sound instead, as long as we respected, the particulars of the syntax that would be involved in the other kind of game object, we could relatively easily trigger other kinds of events through using this same logic